Hello students, this is Miss Dalton and I'm going to work through the Unit 2 review to help you prepare for the test. When it's asking you for the vertex, it's asking you for this point right here. And so that point is the ordered pair 2, -1. This absolute value opens up. The domain, you can just write in an interval notation. The domain for all absolute value functions is going to be -infinity to +infinity. The range in interval notation, remember you want to go from the bottom up to the top, and we're looking for the y values. Well, the y value at the bottom of this graph is -1. And it's going to have a bracket because that is a solid point. So it's going to go from -1 all the way up to the top, which is infinity. And infinity always has parentheses. Write the function in vertex form. So to do that, you want to remember that your vertex is considered your h and k. So here's my h, and notice that it's going to go in as an opposite. So if it's +2, then when we write it in this notation, it's going to go in as an x -2. And then at the end, the plus k is exactly what k is, so it's going to be a -1. Now to get your a value, you're going to count your slope going to the right side, so going from your vertex to the point on the right side. Well, if you notice that I've got another point right here, and my slope would be up 1 to the right 1, which would be +1 over +1, so my a value is just 1. You can either put the 1 there if you want to, or you don't have to, because that's just understood that there's a 1 there if there's no number there. Describe the transformations of the graph. Well, because the a value is 1, it did not stretch or shrink. The only thing that it did, and so remember we're going from, the parent function absolute value, which is here. So which way did it move? Well, it shifted to the right 2, and it shifted down 1. So those are your transformations. What quadrants does the graph lie in? So remember your quadrants, they make a C. So this would be quadrant 1, this would be quadrant 2, this would be quadrant 3, and this would be quadrant 4. And so the graph lies in quadrant 1, 2, and 4. Moving on to problem 2, it says given the function g of x equals 2/3 of absolute value x minus 3, write an equation that represents the function reflecting over the x-axis, shifted to the right 4, and then down 2. Okay, so the transformations that I'm looking at here is that it says it's reflecting over the x-axis. When you reflect over the x-axis, you're going to do the opposite of a. So since a is positive, it's now going to become a negative. The second transformation says that it's shifted to the right 4. Well, in order to get it to go to the right 4, you have to, in your equation, you're going to do the opposite. So you're going to subtract 4 on that x there. And then down 2 is going to make me add a -2 to this -3 that's already there. So let's go ahead and write what the finished function will look like. So it'll be g of x equals -2/3 absolute value of x minus 4. And then -3 minus 2, that's going to give you that -5. So this is your finished function. Okay, part 3 says describe how the graph of f of x equals -3 absolute value of x plus 1 minus 2 transforms from the parent function. Then determine the domain and range without graphing it. Okay, so again, we need to go ahead and state what this represents. We need to state what this represents. We need to state what this represents. And then we also need to state what this represents. Okay, well, let's start with the negative. The negative is going to make it reflect over the x-axis. Make sure you get that right. If it's on the outside, it flips over the x-axis. The 3, because 3 is larger than 1, then that is going to be a vertical stretch by 3. The plus 1, remember that lies to you. It's going to shift to the left 1. And then the minus 2 is going to shift down 2. All right, the domain, well, again, for absolute value, your domain is always going to be all real numbers. So written in interval notation, that would just be negative infinity, infinity. That will never change. However, your range will change. And just kind of, you know, think about what this is going to look like. Obviously, it's going to open down, right? Because it's negative. And then your vertex right here is going to be the point -1, 2. I'm sorry, -1, -2. And your range is always based on your y values. We want to go from the bottom to the top. So the bottom is going to negative infinity. The top is right there at that y value of -2. So we're just going to put -2 and then make sure you put brackets. All right, moving on to number 4. Remember, when you're solving graphically, you want to graph this part of the equation first. So using your absolute value graphing skills, go ahead and graph that. And then we're going to graph the horizontal line that's at this constant. So let's go ahead and do that. So the absolute value is going to have a vertex of 1, 3. So if I graph that here, there's my vertex. It opens up, and it opens up with a slope of 1. So you just go up 1 over 1 and keep doing that, and that's going to get you your right side of your graph. And then the left side of the graph should be symmetrical. So it's going to be over here, and then go up 1 over 1 here, up 1 over 1 here. Now let's go ahead and try and graph those lines. So I'm going to try and draw a straight line, straight as I can. Okay, then you're going to graph your horizontal line at y equals 6. So my horizontal line will be right here at y equals 6. Now, for solving, what you're looking for is you're looking for where those two graphs cross. So they cross here and they cross here. Since we're just looking for the x value, then my two solutions are x equals -2 and +4. So that's how you can graph it graphically. Remember, you will have access to Desmos or a graphing calculator on the test. And honestly, Desmos is a little bit easier for this, because on Desmos you can just put your cursor on that point and it'll tell you what your x values are. Okay, now if I'm wanting to solve it algebraically, then let's look at number 5. Algebraically is what you've had the most practice with. You're going to subtract 5. This cancels, so we bring down the 1/4 absolute value, 3x minus 1 equals 7 minus 5 is 2. Now, to divide by a fraction, we don't really recommend that, but what we do recommend is multiplying by the reciprocal. The reciprocal would just be 4 over 1. So 4 over 1 is the same thing as 4. That's going to get this to cancel here, and so you'll just have the absolute value of 3x minus 1 equals 2 times 4 is 8. Now at this point you would want to double check that the absolute value is equal to a positive, and it is, and so now at this point you would split it. So you would have 3x minus 1 equals positive 8, and you would have 3x minus 1 equals negative 8. Keep solving it, so add 1, 3x equals 9, divide by 3, x equals 3. Over here, I would add 1, that gives you 3x equals negative 7, divide by 3, so x equals a negative 7/3. Sorry about that airplane, as you can tell I'm outside recording this. Complete the number line with the solutions. So if this is 0, I'm going to have a solution at 1, 2, 3. So I can just put a point there. And then negative 7/3, that's the same thing as negative 2 1/3. So negative 1, negative 2. If this is negative 3, this is negative 2. It's just going to be a little bit past negative 2 right there. And then just go ahead and write down your solutions. X equals 3 and a negative 7/3. Okay, let's move on to number 6. Number 6 just says to graph f of x equals negative 2, absolute value of x plus 3 plus 5. And so we're just going to graph our vertex first. Remember, your vertex is your HK. H is opposite, so my vertex is going to be negative 3, positive 5. So go to negative 3, positive 5, and put a point. Now my A value is negative 2. Now remember, that's negative 2 over 1. So if I use my slope, I go down 2 and to the right 1. And there's my next point. I can do it again, down 2 to the right 1. And then I can keep doing that if I want to. But remember, the symmetrical piece on the other side, it would be going down 2 to the left 1. And then down 2 to the left 1. And so there we have our absolute value. Whoops, that was a terrible line trying to connect those points, but you get the idea. Okay, now number 7 is solving. This is solving an inequality, and so let me talk to you a little bit about this. First of all, you would go ahead and graph the inequality. Now, I'm sorry, not the inequality, the absolute value. Now, I'm actually going to flip this around a little bit because it's just a little bit easier to look at. So if I have 4 absolute value x minus 5, I want to make sure that this is still pointing at that. So I'm going to turn it around and have it go this way because it still needs to point at that absolute value. And then 3 is on the other side. So we're going to graph this absolute value first. This absolute value has a vertex at 0, negative 5. And then we're going to go up 4 and over 1. We could do it again, 1, 2, 3, 4 over 1. And then we're also going to have that symmetrical piece, so up 4 to the left 1. And then go up 4 to the left 1 again. So here's what our absolute value function looks like. Okay, then we're also going to graph this other side just with a horizontal line at y equals 3. So that's going to go across right here. Now we can see where it crosses, but because we have an inequality, What this is saying is when is the absolute value function less than or equal to this value of 3? Well, less than or equal to is this whole section right here. So basically it's anything that's below that horizontal line of 3. Because this is connected, then we know that we're going to have a between statement, which looks like this. And remember, you're always going to put your lowest value here and your greatest value here. So if I look at this point right here at -2 is the least value. The greatest value is at +2. And because this starts with a line under it, then you're also going to have a line under your solutions. And so this is how you how you solve an inequality graphically. Now let me just point out that let's say if this said greater than or equal to 3. If it was greater than or equal to, you would look at the pieces that are above that blue line. Well, this piece and this piece is above the blue line. And so what you would want to do is you would have to say it's a separate inequality. It's all of the x values that are less than or equal to -2, or it's all the x values greater than or equal to 2. Okay, and this was in my video that you were supposed to watch before we did the inequality lesson. Okay, moving on to number 8. It says shifted, so write a new equation that represents the function shifted 2 units to the left. So we're going to do that first. 2 units to the left is actually going to be a +2 inside with that x. Then it also says 3 units up. 3 units up, we're going to add 3 to the end here. And then it says vertically compressed by a factor of 1/2, and so that's going to just go at the front here. And so your new function would be 1/2 absolute value x plus 2, and then +2 + 3 would be that +5. All right, so we have another solve algebraically and place the solution set on the number line below. So you have to get that absolute value by itself, so we're going to divide both sides by -3. So that gives us the absolute value of x plus 1 equals 4. It does equal a positive, so then now you can split it, and you can have x plus 1 equals 4, and x plus 1 equals -4. So I'm going to write it below here. If I subtract 1 here, this would be x equals 3. If I subtract 1 here, that would be x equals -5. So if I draw that on my number line, let's say this is 0, 1, 2, 3, I would have a point there, and then -1, 2, 3, 4, 5, I would also have a point at -5. All right, let's look at number 10. So it says solve algebraically, another equation. So instead of dividing by that fraction, we're going to multiply both sides by 3. That would be the reciprocal. So this cancels. You would have the absolute value of 2x minus 7 equals 15. It does equal a positive, so now we can split it. 2x minus 7 equals 15, and 2x minus 7 equals -15. You would add 7, so 2x equals 22, and then divide by 2, x would be equal to 11. If you add 7 here, you would get 2x equals -8, and then divide by 2, x equals -4. So let's put 0 here. We'd have negative 1, 2, 3, 4. We would have our solution there. Then we would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We would also have a solution there. But these would be your answers for your solutions. Okay, so let's move on to a solving inequality. So you want to get your absolute value by itself, so I'd divide by 2. I'm not dividing by negative, so I don't have to flip my inequality, so this would be 1 minus 3x absolute value greater than or equal to 4. At this point, you will split it. When you split it to the positive 4, it stays the same, so 1 minus 3x, you just take the absolute value bars off, but the inequality would stay, greater than or equal to 4. When you move it to the negative side, the negative 4, you do have to flip the inequality. So 1 minus 3x is less than or equal to negative 4. So just remember to flip it when you go to the negative side. Here I'm going to subtract 1. Negative 3x is greater than or equal to 3. Now because I'm dividing by a negative, I do need to flip it again. So it would be x is less than or equal to, negative 1. So when you divide by a negative, you have to flip that inequality. Okay? Over on this side, we would subtract 1. That would give you negative 3x less than or equal to negative 5. And then when I divide by that negative, again, I would have to flip it. So this would make me flip that. So I would have x is greater than or equal to a positive 5/3. Okay, so let's go ahead and see where that falls on the number line. Let's go ahead and put, if I put 0, I'm going to put it way over here. If I put 0 here, negative 1 would be here. I would have a solid point, and then it says x is less than or equal to. Well, less than or equal to would be on this side. So just draw a quick sketch showing that it's going to shade this way. 5/3 is the same thing as 1 2/3. So 1, 2. So this is 2, this is 1. 1 2/3 would be, I don't know, approximately here. And because it says x is greater than or equal to, then it's going to go this way. And since they are not connected, then you would leave your inequalities not connected, and you would just put an or. If it shades in, then it would be an and statement, and you would have to write your inequalities together. Okay, moving on to the last problem. It says, which graph lies entirely in quadrant 1 and 2, and then write the range for each function. Well, something that I want to point out is our quadrants. I've stated this before, but our quadrants, here's quadrant 1, here's quadrant 2, here's quadrant 3, and here's quadrant 4. So in order for it to only lie in quadrant 1 and 2, it would have to open up, and the vertex would be above the x-axis. So this one, part A, the negative 4 is going to make it open down. Okay, so that can't happen. The other one that's making it open down is this one here. That can't happen either. So at this point, I've got to decide where these vertices are. Okay, so the vertex for part B, the vertex would be -3, +2. The vertex for part C would be -3, -2. Okay, well, let's see where those vertices are. Part B, -3, +2 would be right here. So this is part B. -3, -2 would be right here. And this is part C. Well, the only way that it would stay in quadrant 2 would be part B. And so this is your answer. Now the other thing, it wants for you to write the range. Remember, the range is based on, is it opening up, down, and then also the y value of your vertex. So this one right here is opening down, and the vertex is -3, 2. Well, if it's opening down, then that means the bottom part of my range is at -infinity. The top part of my range is at that y value of 2. Okay, this next one opens up. So if it opens up, then you're going to have the right side be infinity. The top of it's going to go on to infinity. The bottom is your vertex at 2. Okay, now if we look at part C, this one opens up 2. So the range is going to be, the bottom is my vertex at -2, and then it's going to go on to infinity. The last piece, last part D, my vertex is 3, 2. It's opening down, so the bottom of my picture is going to be at -infinity. The top is going to be at 2. Okay, so I hope this was helpful. Just make sure that you're ready for your test tomorrow, and looking forward to seeing you.